Hello students, welcome to my channel. In today's video I am going to discuss about the polar coordinate system, and this is a very important topic which is included in the syllabus of B.Sc mathematics, and also if you are a physics student, maybe you have studied this earlier. So without any further delay, let's move forward to the discussion. So still now we have studied about the Cartesian or the rectangular coordinate system. In that system of coordinates we just take two perpendicular lines like this, and these lines are called the axes. So this is our x-axis and this is our y-axis, and the point at which they intersect is called the origin O. So this is the rectangular Cartesian coordinate system, and with this reference we can locate the position of any point P in this two-dimensional plane. Okay, but in this polar coordinate system we need not take two reference lines, rather we just have to take one fixed point and one fixed line, one fixed point O and one fixed line OX. This fixed point is called the pole or the origin, and this fixed line OX is called the initial line. Initial line. Okay. With this reference, we can locate the position of any point in this plane. How? Let this point, this is a point in this plane P. Now we shall connect this point to the pole, and say this distance is R, and the angle made in anti-clockwise direction with the initial line is theta. Okay. So if we change R, the location of the point will be changed, and if we change theta, similarly, if we change theta, the location of the points will be changed and different points will be obtained. So thus, with these two coordinates R, theta, we can locate the position of any point in this polar coordinate system. Okay, so this is the basic of our polar coordinate system. Now this distance R is termed as radius vector. Radius vector. No, it doesn't mean that it's a vector. Yes, there are similarities between vectors which we can use as analogy, but no, it's not vector. It's just a term called radius vector, like we term the area vector. Similarly, this is also a term called radius vector, and this angle theta is called the vectorial angle. Vectorial angle of point P. Okay. Now we shall derive the relation between these two systems of coordinates. So let us draw the Cartesian coordinate system. This is our x-axis and this is our y-axis. So this is origin or pole O. Say OX is the initial line. OX is the initial line. This is our pole or origin, and OX is the initial line. Initial line. Okay. So if we take any point in this coordinate system, say this point is P. With respect to the Cartesian coordinate system, the location or the coordinates of this point is x, y. And with respect to the polar coordinate system, the coordinates of this point is r, theta. So if we connect this point to the origin or pole, this distance is r and this angle is theta. And with respect to the Cartesian coordinate system, if we draw perpendicular from here, this length is x and this length is y. So now we can find the relation between these two systems of coordinates by using trigonometry. How? With respect to this angle theta, if we can write cos theta will be equal to base upon hypotenuse. So x divided by r. From here we can derive x is equal to r cos theta. Similarly, we can write sin theta is equal to perpendicular divided by hypotenuse. So perpendicular is y and the hypotenuse is r. So y is equal to r sin theta. This is the relation between these two systems of coordinates. Okay, we can think this as vector also. Like say if r is a vector, just suppose if r is a vector, then we know that the vectorial component of r along x direction is r cos theta. The vectorial component means the effective part of this vector r along this direction. If this angle is theta, then this component is called r cos theta, and the perpendicular to this component is known as r sin theta. So you can remember this like that, that if this is a vector r, then x is equal to r cos theta and y is equal to r sin theta. However, it's easy to derive the formula by using simple trigonometry. So students, let's solve the problem. See, transform the equation this to its corresponding polar form. Now, we just found the relation between Cartesian system of coordinates and polar system of coordinates. Now, this equation is given in its Cartesian form, and we have to transform this equation into its polar form. So, if we take any point in Cartesian plane and denote it by x, y, the same point is denoted in polar system of coordinate by r, theta. Then we know the relation that x is equal to r cos theta and y is equal to r sin theta. Now we can replace this x and y in this equation and we will get the required polar equation. So this becomes r square cos square theta plus r square sin square theta whole square is equal to 9 into r square, x square means r square cos square theta into y means r sin theta. Then if we take r square common, then sin square theta plus cos square theta is equal to 1, and here is whole square. So this becomes r to the power 4 is equal to 9 r cube. R to the power 4 is equal to 9 r cube cos square theta into sin theta, and this is the required transform equation in polar form. Okay, so now we shall derive the distance formula between any two points in polar coordinate system. So we already know the distance formula between any two points in rectangular coordinate system. If point A has coordinates x1, y1 and point B has coordinates x2, y2, then the distance between AB in rectangular coordinate system is root over x2 minus x1 whole square plus y2 minus y1 whole square. This unit. Okay, so we know the relation between rectangular and polar coordinate systems. Thus, we can write x1 from this diagram. We can write x1, this length is r2, this length is r1, and this entire angle is theta 1. This angle is theta 2. So this angle is theta 1 minus theta 2. Now, x1 is equal to r1 cos theta 1, and x2 is equal to r2 cos theta 2. Okay, so from here we can replace x1 y1 and x2 y2 by this r1 cos theta 1 and r2 cos theta 2, and then we shall get similarly y1 is equal to r1 sin theta 1 and y2 is equal to r2 sin theta 2. By replacing this here, we get the formula to find the distance between any two points in polar coordinate system, and then distance AB is equal to root over r1 square plus r2 square minus 2 r1 r2 cos of theta 2 minus theta 1, or you can write theta 1 minus theta 2 also, it doesn't matter. So units, this unit. Okay, so this is the distance formula between any two points in polar coordinate system whose coordinates are r1 theta 1 and r2 theta 2. Thank you everyone, this is all for today's session. If you have any doubts regarding the discussion, let me know in the comment section. Also for the PDF notes of this session, you can check out the description box below. And this is a very introductory session where I have discussed all the basics and fundamentals of polar coordinate system. In my next videos, I will go into the depth of the topic. Till then, keep studying and keep growing.